hello to all you, our lovely grade 10 mindsetters. Welcome to the last live show of Learn Extra Live. Yes, unfortunately, it is the last live show with us, but you guys do not despair because from next week on, we will still be continuing with revision and all sorts of types of help that we can possibly give to you guys. And on that note of the last live show, we also are on the last week of our hashtag Get Connected competition. Remember that all you guys had to do was vote for the teachers that you completely love and admire on our Facebook page by simply liking their photo or going onto Curio and also liking their post there as well. And guys, I am not alone in studio today. I go by the lovely name of Queen Matoso, and I've got a lovely teacher with us today. How are you, Natasha?
I'm very well, thanks, Queen, and I'm so sad it is the last live show of the year. It's incredible how quickly this year has come and gone. It really is. And Queen, I have to pick up on that Get Connected. Guys, you have to vote for the maths show. Come on, we want the girls to top the boys. Hey, I think it's the boys that are winning now. No ways. We've got to have the girls winning this one.
Yes,
Queen.
guys, so please do vote for Natasha. It is very easy and simple. Just go into our Facebook page and you'll find her picture there. And all you have to do is like. So please tell your friends about it. Share the picture with your friends on Facebook. Let them know that you want your favorite teacher to win. So it's all about women power. Please vote for Natasha, guys. Come on, come on. We need to get those things coming in. And guys, also remember that this show is all about you. So please get connected with us, interact with us on our social media pages. And that is at www.facebook.com/Learn Extra, or you can also go into our Twitter, and that is at Learn Extra with an X. Or you can also go onto our website, and that is at learn.mindset.co.za to get yourself all the notes, all the revision notes, and anything else that you could possibly need. We've got so much material for you guys, so you have no excuse. Come on, guys, we need to pass these final exams. And with that all being said, let's get straight into the show, and let's see what we're actually here for, Natasha.
All right, Queen. So what we're doing today, grade 10's probability calculations. Last week we looked at the introduction of probability, and we looked at some really easy examples, right? So today we're going to get involved with the sort of harder examples, but not really. It's got just examples that are going to get your brains ticking over. Specifically, we're going to look at mutually exclusive events, complementary events, calculate probabilities, and we're also going to do a little bit with tree diagrams. So Queen, should I get straight into our challenge question?
I think you should go straight into it. Let's see what we have.
All right, guys. So let's look at your challenge question. Remember to answer this and send the answers to Queen, or if you're getting stuck, let us know and we'll see where we can help you. So your challenge question for today, grade 10s. About 20% of the southern hemisphere is land. All right? Only 20% is land. South Africa takes up about 5% of the land surface of the southern hemisphere. A meteorite is falling to Earth, and it could hit anywhere randomly. Calculate the probability that, firstly, it will hit the southern hemisphere, part B, that it will hit land. All right, so it's going to hit some sort of land in the southern hemisphere, or part C, calculate the probability that it will hit the sea, so it's going to hit water if it does land in the southern hemisphere. And then the last part of that, part D, calculate the probability that it will hit South Africa. This is quite a nice question, quite a nice challenge question, and I hope that you guys get stuck in it. It's one of those to really get your brains thinking. All right, so I want to see what answers you come up with. But let's get straight into the lesson for today to help you get to that challenge question and hopefully answer it even better than you would at the start of this lesson. So this is just a summary of what we're going to be looking at and what we're going to be using in today's lesson. Okay? When all the outcomes of an activity are equally likely to happen, you can calculate the probability of an event P occurring by using the probability of an event E. Probability of E is equal to the number of favorable outcomes divided by the number of possible outcomes. Okay, all of you guys should be familiar with that, and all of you should have been using that by now to answer your questions thus far. Okay, so keep thing that you need to remember. Another key point is the probability identity. If you want to find the probability of A union B, so the probability of A or B, that is equal to the probability of A plus the probability of B minus the probability of their intersection. Now, the fact that two events do intersect tell us that they're not mutually exclusive, but we'll look at that a little bit later. If the two events are intersecting, it means that their intersection is not 0. Okay, so you use this probability identity when the union has an intersection of events. All right. Mutually exclusive events. These are events that cannot occur at the same time. Mutually exclusive, what does it mean? For example, you cannot be asleep and you cannot be eating at the same time. Those things are mutually exclusive. They cannot happen at exactly the same time. You cannot be running and swimming at the same time. Mutually exclusive. So that means that their intersection, the probability of those two events intersecting is 0. Okay, so mutually exclusive events are events that have no intersection. If A and B, so your two events A and B, if they are mutually exclusive, then the probability of their union, probability A union B, is just the sum of the probabilities. We don't subtract the intersection because remember, when events are mutually exclusive, the probability of their intersection is 0. All right, so the probability of mutually exclusive events intersecting is 0. Okay, and then when we go back up, just to remind you here, when the two events are not mutually exclusive, so in other words, they can intersect, then their probability will not be equal to 0. We would be able to assign a value to that. Okay. Complementary events. So these are not events that give complements to each other. Complementary events are mutually exclusive, which means they cannot happen at the same time. So for example, if you think about tossing a coin, you can either get a heads on the toss of the coin or you can get a tails on the toss of the coin. It's not possible to get both heads and tails at the same time. So those two events are mutually exclusive and they are also complementary. Another way that you can test that events are complementary is that if they are complementary, then the sum of their probability will be equal to 1. All right? So we can also say here, if I wanted to find the probability of event A happening, it would be 1 minus the probability of event B. Also note that A can be written as B prime or as not B. So the probability of getting event A, you can actually, instead of saying probability of A, you can say complement, you can say B complement or not B. Okay, both are acceptable. With that summary, guys, I think let's get straight into the first question. We're going to use all of that information that I have just shown you, and let's answer question 1. So we're going to start off nice and easy. We've got a fruit bowl containing 5 apples, 3 bananas, and 2 oranges. So altogether, 5 plus 3 plus 2, we've got 10 fruit. Okay, so that's our total sample space. It includes 10 fruit. If a fruit is randomly selected from the bowl, calculate the probability that the fruit selected will be, part A, we're looking for you getting an apple or a banana. So we're looking at the probability of getting an apple. So A for apple, union, or a banana. Okay, now think about this. What are we going to use here? I want to find the probability of getting an apple or banana. Think of it in terms of your identity. We know that, and I've shown you, the probability of A union B is the probability of A plus the probability of B minus the probability of their intersection. However, when we look at this example, we want to choose an apple or a banana. Can the fruit be an apple and a banana at the same time? Can there be an intersection? No, I don't think so, unless there's some sort of strange fruit genetic engineering going on. It's not possible. Your fruit cannot be an apple and a banana at the same time. So therefore, we know that the probability of the intersection of these two is going to be 0. There's no intersection. Okay, so therefore the probability of A union B, so the probability of apple or banana, is going to be the probability of the fruit being an apple plus the probability of it being a banana, because those two events are mutually exclusive. So what is the probability that we choose an apple? Well, there's 5 apples in the bowl, there's 10 fruit altogether, so therefore the probability of getting an apple will be number of favorable outcomes divided by number of possible outcomes, plus the probability of getting a banana. There's 3 bananas in the bowl, there's 10 fruit altogether, so that's going to be 3 over 10. So therefore, the probability of getting apple or banana is going to be 8 out of 10, or 80%, or 4 over 5 if we simplify that. So 2 goes into 8 4 times, 2 goes into 10 5 times. You can leave it as a fraction. Okay, and I said this last week as well. You can leave your answers as fractions, you can leave your answers as decimals or percentages. Sometimes the question might say write your answer in percentage form, then obviously write it in percentage form. Okay, let's look at part B. Calculate the probability that the fruit selected is not a banana. So if it's not a banana, what are the options here? It could either be an apple or it could be an orange. All right, so if it's not a banana, it can either be an apple or an orange. So therefore, the probability of not banana, so this is part B, probability of not getting B is going to be the probability of it being an apple plus the probability of it being an orange. All right, we know that there were 5 apples in the bowl, so therefore the probability of it being an apple stays the same, 5 out of 10, plus the probability of it being an orange. They told you 2 oranges in the bowl, that's going to be 2 out of 10, so therefore we will get 7 out of 10, which is 70% or 0.7. All right, so you've got a 70% chance of choosing a fruit other than a banana from your fruit bowl. All right, with all of that information, let it sink in, digest it, and let us know if you have any questions, Queen.
Yes, guys, please remember to connect with us, hit us up on Facebook, communicate with us, and so far, I can see that you guys are actually figuring out the challenge question, which is actually great. You've already got 2 answers there, but we can only reveal the correct answer at the end of the show. And from there on, there are no questions.
Fantastic. So should we go to a quick break?
All right, so let's take a quick ad break then. This gives you a chance to hit the challenge question, try to figure it out, and also try to see if there are anything that you are struggling with that Natasha has done so far. But let us give you that break, so then we'll see you after this. Welcome back, grade 10s. You are still tuned in with us on Learn Extra Live, the mathematics show with myself and Natasha. And if you've just joined us, do not despair. We have not gone through a lot yet, so you can still catch on. And remember, guys, that our hashtag Get Connected competition is still running. I cannot emphasize this anymore. It is the last week, so please get voting. Vote for your favorite teacher. And today we've got Natasha on. So if you love Natasha, I mean, like, you have no reason not to love Natasha. So please kindly just like her picture on our Facebook page. And that is it. So let's continue with the lesson of today.
Yes, okay. So go ahead, like the picture. Also, Queen, I know they can win a cell phone. So what more
Yes,
reason do you
definitely.
need,
There's a lot of prizes to be won.
Fantastic. All right, guys. So we're going to carry on with the lesson. This is question 2. Improve your skills. In a class of 38 learners at a girls' school, you are told that 24 play piano, 30 play the guitar, 4 play neither instrument. If a girl is chosen at random, calculate the probability that she plays, and then there's a whole lot of questions. But firstly, let's have a look at this question. They've given you quite a bit of information. You've got 38 learners, 24 playing piano, 30 playing guitar, and 4 playing neither instrument. Now, there's probably a couple of things you can do to answer this. You can draw a table up and list all the information there, or you can draw a Venn diagram. Venn diagrams are a very useful way to answer probability questions, especially when they give you a lot of information. So I'm going to use a Venn diagram, but if you want to use the table, feel free to draw up a table, but it is very important for you guys to understand Venn diagrams, and so that's what I'm going to do with question 2 and then later on with question 3 as well. All right, so how do we draw up our Venn diagram? Now, I often get asked, can we only use squares and a circle? Yes, you can use whatever shapes you want, but because you guys are more familiar with the square on the outside to represent the sample space and then the circles, that's what I'm going to use. But if you can use whatever you want, whatever shape you want. All right, so we're going to have, or a rectangle rather than a square. As it turns out, my shape is more rectangular than squarish. All right. There we go. So this is going to represent our entire sample space. And it doesn't have to be perfect. There we go. I'm going to try and get it as perfect as possible. There. So that's going to represent our entire sample space S. All right? And then inside of there, we're going to put 2 circles to represent each of the sets, which I'm going to show you how we get to now. All right, so I'm going to have these 2 circles, and then we're going to decide whether they intersect or they don't intersect from the given information. All right. So they told you altogether you have 38 learners. So therefore, this entire sample space, the number of elements there, has got to be 38 overall, okay, when you add everything together. They tell you that 24 play the piano. So firstly, what I'm going to do so that we keep everything in order, I'm going to say let event A be the event that you are, or this girl is playing the piano. Okay, so event A is playing piano, and we're going to say let event B be equal to playing guitar. All right, so they either play piano or they play guitar. All right, and we're going to have those 2 events represented by our circles. We know that 24 play the piano, 30 play the guitar, and 4 play neither instrument. Now, you've got to decide from your given information, where's the easiest point to start? And I think the easiest point here is going to be representing the fact that 4 play neither instrument, because remember, those that are not represented in these 2 circles stay outside of the circle. So it shows you that those 4 are not involved in piano playing or guitar playing. Okay, so that's the easiest thing to represent. Also, guys, if 4 play neither instrument, this implies that 38 minus 4 will give me 34. 34 learners altogether. So altogether, when you add everything up, 34 learners play either piano or guitar. So when you add everything up, 34 of them play either instrument. All right. Is there an intersection? Well, there must be, because the first question says how many play piano and guitar. And also from the given information, we realize that these 2 are going to intersect. Let's just get rid of that. There we go. They're going to intersect, so we want to make them intersect. All right? I'm going to call the one event A, the one circle A, and then the other one is B. We know there are 34 learners that play both instruments all together. So how do we decide what this intersection is? We've got 24 playing piano, 30 playing guitar. So in order to work out your intersection, the number that play both piano and guitar, and we need this Venn diagram. It's going to make answering these questions A, B, C, D really, really easy. How do I determine how many play both piano and guitar? Well, have a look. You've got 34 altogether, we know that, right? That are playing either instrument. 24 playing the piano, 30 playing the guitar. So that gives me 54 girls. But we've only got 34 to work with. Doesn't make sense. So that means there must be an intersection, because now we've got too many elements, right? So therefore, how do I work out the intersection? 54, which is the total that we get from the given information, minus, we know that their union must be 34 from the information that they gave us, which was 38 learners altogether. 4 play neither instrument. Therefore, 34 must play either instrument. 54 minus 34 gives me 20, and therefore my intersection must be 20. All right, so I want to just repeat that again, because I know that this is the part where you guys struggle, working out the intersection. This is the toughest part. You read your question. There's no foolproof method, because remember, each and every question can be different. But the nice thing about maths is the more you practice, the more likely you are to see similar questions being asked. So here, what were we given? We were given the total number of learners. We were told how many play neither instrument. That helped us to determine how many played the instruments that we were interested in, which is the piano and the guitar. We then saw from the given information there must be an intersection, because if we added the number of girls together, 24 plus 30, we got 54, which was greater than the total amount of people that we are dealing with. We then subtracted what we know the number of learners should be that play either instrument, and we got the intersection of 20. All right, now let's fill in the rest of this Venn diagram. 24 girls play the piano. We know that 20 play both instruments, therefore 4 must play the piano only. All right, 30 play the guitar, 20 play both instruments, 30 minus 20, 10. Therefore 10 play the guitar only. All right, and you see from setting this up, from setting this Venn diagram up, we can now answer every question with very little thought, really, because everything's been done and set up for us on that Venn diagram. So let's have a look at part A. And it says, calculate the probability that this girl that's chosen plays the piano and the guitar. So the probability of A intersection B. All right, so we're going to read everything off straight from our diagram. Probability of A intersection B, and we know that that is 20. We've already worked it out, so therefore it's going to be the probability is 20, number of favorable divided by number of possible outcomes. And that gives us 2 goes into 20 10 times, and 2 goes into 38 19 times. We can leave it as 10 out of 19. But you see how simple it was when we worked out this intersection from the Venn diagram. It's then easy to answer the questions on probability. So this is your starting point. All right. Part B. How many, calculate the probability that she plays the piano only. Now remember, 24 altogether play the piano. We want to know how many play the piano only. So 24 minus the intersection of 20 gives me just 4 of them that play the piano only. So the probability of A only is going to be equal to 4 over 38. All right, why 38? Well, we're choosing from 38 possible people in this class. 4 divided by 38, 2 goes into 4 twice, 2 goes into 38 19 times. All right? Part C. We want the probability that the person plays neither instrument. Well, that's nice and easy because they gave that to us. The probability of playing neither is going to be 4 out of 38 as well, because they told us that 4 of these girls play neither instruments, and that gives us 2 out of 19. All right, and where are we now? Calculate the probability that she plays the piano or the guitar. So the probability of the union of these two events. Probability of A union B, remember from your identity, that's equal to the probability of A plus the probability of B minus the intersection. All right? The probability of A we got was from our, so it's going to be the probability of A, which is 24 over 38, plus the probability of B, which was 30 over 38. And then obviously we've got to subtract the intersection, otherwise we're going to end up with too many elements there. So that's going to give us 54 minus 20, which is 34 over 38. All right, 2 goes into 34 17 times, and 2 goes into 38 19 times. So it's 17 over 19. That is our probability of them playing either piano or guitar. So the probability of the union. Queen, let's just check over with you and see if we've got any questions or any comments on this question too.
Yes, we actually have a question from Clarence, and she would like to know if it's possible to answer question 2 with a tree diagram.
A tree diagram, you could. I don't really think you could. I mean, you possibly could. The problem with the tree diagram is that you're going to have 3 branches, which is quite difficult to work with because you're going to have piano, you're going to have guitar, and then you're going to have neither. So a tree diagram would be far too complicated to work with this. And remember, with a tree diagram, we generally use it for compound events, so events happening at the same time. So something like tossing a coin and throwing a dice, that would be an excellent time to use the tree diagram. Not necessarily in a question like this. A question like this, more your table or the Venn diagram, definitely. But a nice question there. Thanks for asking that one.
All right.
All right.
Hope we cleared out the question for you. And that's
Is that
all.
it?
Yes,
all right,
that's it.
great. So let's have a look at question 3. So question 3, again, guys, as I said to you before, I'm going to use a Venn diagram to do this. You can do this with the table. No, the tree diagram is not the best way to do this, okay? Because remember, in maths, you want to keep things as simple as possible. Tree diagram is going to complicate a question like this. So we're told here that customers at a shop were asked if they had bought milk, meat, or both. Okay, so we're dealing with milk, meat, or both. 150 people were questioned, and the answers were 125 bought milk, 85 bought meat, and 70 bought both. All right. They then say, how many bought neither milk nor meat? So let's have a look at what we've got here. Let's look at the information again. You've got 150 people being questioned. They tell you 125 bought milk, so I'm going to say, let the event of buying milk, let that be equal to A. All right, and then we've got people buying meat, so let this event of buying meat, let that be equal to B. All right, the first question says, how many bought neither milk nor meat? We don't really need a diagram to answer this one. We can work it straight from the given information. You've got 150 people buying things. If you add up 125 plus 85, let's do that. 125 plus 85, you get 210. That number, 210, is more than the actual number of people being questioned. So what do? We subtract out the intersection and we get 140. This 140, what that tells me, guys, all right, what that 140 tells me is that altogether, the 140 people either bought milk or bought meat. So in other words, and I know this is a question that comes up later, but A union B, the number of people that bought either milk or meat, that is equal to 140. So what I did is I took the number of people that bought milk added it to the number that bought meat, and then obviously remembering to subtract the intersection, otherwise there's double counting, and therefore we get 140 people bought either milk or meat. So therefore, the number of people that bought neither, well, it's simply going to be 150 minus 140, so it's going to be 10 people who bought neither milk nor meat. All right. Okay, that information is actually going to help us to answer question B, which says, draw a Venn diagram to illustrate this information that they've given you. All right, so let's draw our Venn diagram, and this time, because I drew it nice and neatly the last time, you have the idea, so let's go straight into it. So that represents our entire sample space. We've got 2 circles to represent our events. We know that these events intersect. So A is buying, what did we say there? Event A was buying milk, and event B was buying meat. We know from what we've just answered that 10 people are out of those 2 events. They did not buy either milk or neither milk nor meat. All right? You've got the intersection. It's nice this time because you know what the intersection is. 70 bought both. So this number in between here, that's going to be 70. They tell you that 125 bought milk. So how many bought only milk? So 125, that's including your intersection of 70, remember. So we've got to say 125 minus 70, and that gives me 55. That tells me how many people bought only milk. All right. And then we don't really need the calculator for this one. They said 85 bought meat. So 85 minus the intersection of 70 is 15. Remember, when they give you this information, 125 bought milk, 85 bought meat, the reason we're subtracting the 70 is because that 70 is already included in that given information. So we need to subtract it out so that we can get the correct diagram. All right. So that is our Venn diagram. Draw a Venn diagram to illustrate. Done. All right, that was part B. Part C, and this has got 2 questions. They say, what is the probability that a randomly chosen customer bought meat but no milk? So in other words, meat but no milk, the probability that someone bought only event A. So they bought meat, and remember that event A was meat, and event B was milk. So what is the probability of A only? You see, when you've got your Venn diagram, it is so simple. We've worked out that 55 people bought only meat, so therefore it's going to be 55 over 150. And I think we can simplify that. Let's have a look. 55 divided by 150. That gives us 11 over 30, or let's write our answers as decimals this time, so it's going to be 0.37. Okay, or 37%. Part 2, what is the probability that the customer bought meat or milk? So basically here, they're asking you for the union of the 2 events. So the probability of A union B from your identity is the probability of A plus the probability of B minus the probability of the intersection. It's standard, it does not change. That's the formula for when you're dealing with events that are not mutually exclusive. So the probability of A we know was 125 over 150. The probability of B was 85 over 150, and the intersection was 70 over 150. So the probability of the intersection was that. Let's work that out. We actually should already have this answer, but let's go through the motion. So it's 125 over 150 plus 85 over 150 minus 70 over 150. Okay, and that gives me 14 out of 15. So 14 out of 15 people would have bought either milk or meat. All right, nice question. I like both those questions. Showing you guys how to use your Venn diagrams to answer. Very, very important. You guys need to be able to interpret Venn diagrams and you need to be able to draw them. Queen, any questions before we take a break?
Yes, we've got a question from Mpo, and he wants to know, or she wants to know rather, how can I know that events are exclusive and exhaustive? I'm not sure if that's what she meant, but she wants to know how can she know that events are exclusive.
Okay, so mutually exclusive events, we discussed this earlier on in the lesson when we did the summary. So mutually exclusive events, it means that those events do not intersect. And the example I used there, I think, was either sleeping or eating. You can't do both at the same time. You're either asleep or you're eating. You can't be asleep and eating. So therefore, their intersection is 0. So mutually exclusive events, their intersection is 0. They cannot occur at the same time. And then she mentioned something about exhaustive. If you think about complementary events, that would be a mutually exclusive event. It's a complementary event. So that means either one of those events have to happen. So if you toss a coin, you're either going to get a head or a tail. So those are mutually exclusive, exhaustive events. All right, and I think that answers that question, Queen.
All right, Mpo, I hope you got your answer. Natasha made it very clear for me, and I hope that you also got it as well. But before we go for a quick ad break, I'd like to just quickly announce our winner for the Casio Calculator Test Yourself competition. And we've got our winner from last week, which is Mandla Mtembu. Well done, Mandla. Like, congratulations, man. You've got yourself a very awesome Casio calculator coming your way. Just stay tuned and we'll give you more information on how you can get a hold of that. But with all that being said, let's take a quick ad break. We'll see you guys after this. Welcome back, grade 10s. You're still tuned in with us on Learn Extra Live, the mathematics show with myself, Queen, and Natasha. And this is our last segment of the show. So we're still going to be continuing with the lesson, but we are actually going to be wrapping it up with this segment. Remember, guys, get voting. Go into our Facebook page, like Natasha's picture if you want her to win the competition for the hashtag Get Connected. And it's all about your favorite teacher winning this competition. But remember that you also get yourself something, and that is airtime voucher worth 60 Rand, and you also get to win a Sony Xperia L cell phone. Now, who would not want that? Hey, who would not want that? So please get voting. And I'd also like to quickly rectify a mistake I made before the ad break. I said the Casio calculator winner was Mandla Mtembu. It's not Mtembu, it's Mandla Mbele. So please forgive me, guys. I don't know what got into me there. And yes, that is it from me. Natasha, we have a quick question from a mindsetter. Do we have time for that?
I think let's quickly have a look before we start our challenge question.
All right, the question is from Moneri Mateja, and she wants to know, she says that her teacher gave them a method for calculating number 1b, which is P NOYB in brackets equals to 1 minus 3 divided by 10. And she wants to know, can she use this method in the exam, or must she rather use the one that you showed them today on the show?
You know, Queen, that's a great question. And guys, that's why maths is so great. It really is the king of all sciences, which is another reason you should be voting to get connected on the maths show, because without maths, none of the other sciences exist. But the thing about this question and maths in particular is that there's more than one way to do anything. Well, most things. Some things there's only one hard and fast set method, but most things you can do it in more than one method. So what that learner was talking about is they wanted to use the complementary rule, which I didn't use to answer this question. I went about it the long way around, but certainly for question 1b, the probability of not getting a banana, you were told that there were 3 bananas. So remember, and I showed you this in the summary, the probability of not B can be the same as 1 minus the probability of B. all right, which is what the learner had asked. So therefore, if I say 1 minus, the probability of getting a banana is 3 out of 10. So 1 minus 3 out of 10 gives me 7 over 10, which is exactly the same answer that we got using the longer route. All right, so certainly acceptable, and definitely please use that method. There are certain questions with the information that they give you that will be much easier to use. All right, let's get straight into the challenge question now, Queen. Do we have people who have answered that for us?
Yes, we actually have a lot of
A
people.
lot of answers.
And mindsetters, I'm very impressed. We have, I'm getting similar answers over here, so I think I know who has the right answer.
Okay, great. So let's see if you've got the right answer, guys. So this was our challenge question for today, and our last challenge question for the Learn Extra Live Grade 10 shows. Okay, last time around. Let's have a look. For this year. Okay, they say about 20% of the southern hemisphere is land. Okay, that information gives me two pieces of information. 20% land, therefore 80% not land. 80% is water. Okay, so that information gives you two pieces of information. South Africa takes up about 5% of the land surface. Again, two pieces of information. If South Africa takes up 5% of the land, that means, and this is off the southern hemisphere, of course, that means 95% is for the rest of the southern hemisphere. A meteorite is falling to Earth, and it could hit anywhere. Anywhere meaning it can hit land or it can hit water. All right? Calculate the probability that it will hit the southern hemisphere. Now, guys, with this one, this is going to be our first introduction to tree diagrams. We haven't done this in our lessons thus far. So a tree diagram is going to really be a representation of compound events, okay? And compound events, these are events that can occur at the same time. And I'm going to use the word independent events, and you guys will really do more of that in grade 11. So let the word independent events hang in your head. It's not really something you expressly get asked about in grade 10, depending on your schools. Some schools do ask you to understand what independent events are. But that's really the concept that you use when you're dealing with compound events and you're dealing with tree diagrams, all right? So let's have a look. 20% of the southern hemisphere is land. And the first question is, calculate the probability that it will hit the southern hemisphere. Now this is where we're going to draw our tree diagram using the information they've given us so far. So a tree diagram, each arm represents information from your question. There's two possible things that can happen here. So what are the two possible things? It can either, this meteorite can hit the southern hemisphere, or the other possibility, the northern hemisphere. It's equally likely, since it's randomly hitting anywhere, it can either hit the south or the northern hemisphere, so therefore the probabilities there are 0,5 each. Okay, again, I'm going to not answer the question immediately, even though the answer is apparent. I want to complete our tree diagram before we go back to answering the rest of the question. From there, now, let's restrict ourselves to the southern hemisphere, because that's where most of your information comes from. They say 20% of the southern hemisphere is land. So let's say that this meteorite did in fact land or end up or hit the southern hemisphere. There's two things that can happen. It can either hit land or it can hit water or sea. Okay, there's two things that can happen, because the southern hemisphere is obviously made up of land and water. And they told you that 20% of the southern hemisphere is land, so in decimal form, 0.2. Therefore, it stands to reason that the other 80% must be water. Also, what you need to bear in mind is on your tree diagram, when you extend your arms, right, the sum of the probabilities on those arms, when you add them up, must always equal 1. 0.2 plus 0.8 is in fact 1. Okay, so the sum of those should always add up to 1 along those arms. Okay, and I'm just going to erase that. Let's put it back in. 0.2, 0.8. Okay, remember we're restricting ourselves to the southern hemisphere, and I'm putting down all the information so that even if by any chance we run out of time, you guys will still be able to go ahead with it. All right. They gave you a little bit more information. So they say South Africa takes up about 5% of the land surface of the southern hemisphere. Now remember, you've got a meteorite. It's going to hit somewhere. It's going to, let's say, hit the southern hemisphere. It's going to hit land. If it hits land, it can hit South Africa. Okay, and that arm we're going to leave for now, and we're going to come back and fill that in a little bit later on. Let's answer the questions based on what we've got so far before I get too carried away with my tree diagrams. Part A says, what is the probability that it will hit the southern hemisphere? Well, we know it's going to be 0.5, 50%, because the hemisphere is 2 parts, southern, northern, equally likely, 1 divided by 2, 0.5. All right, that's part A. Part B says, what is the probability that it's going to hit land, okay, in the southern hemisphere? And that we can get directly from our tree diagram. So we want the probability of it hitting land in the southern hemisphere. So firstly, it's got to hit the southern hemisphere, and then when it hits the southern hemisphere, it's got to land or got to hit land, all right? So it's got to land on some sort of hard surface. So what is the probability of it landing in the southern hemisphere and hitting land? When you look along your tree diagram, you've got the probability of it hitting the southern hemisphere is 0.5. The probability of it hitting land when it gets to the southern hemisphere is 0.2. So if I want the probability of it landing in the southern hemisphere and hitting land, that's going to be the product of those two probabilities. Anywhere along these arms, if you want to get answers, you've got to multiply those two, what we call independent events. All right, or your compound events. So it's going to be 0.5 times 0.2, which will give me 0.1, 10%. Queen, do we have takers? Do people have that answer?
Yes, we actually do.
Fantastic.
We've got answers all over. Yes,
okay,
we've got a lot
great.
of mindsets.
Okay, so some of you understand that. 0.1 is our answer for part B. Now they say, what is the probability that it will hit C in the southern hemisphere? And this is what the other mindsetter was talking about before, where we could just go 1 minus. Okay, but let's have a look. The probability that it's going to, let's just go back to this question. The probability that it's going to hit C, so hit water, in the southern hemisphere. So the outcome that we want there, it's got to land in the southern hemisphere and it's got to hit water. So remember, if you want to get the answers, you've got to multiply along the arms that you're working with. So the probability of it landing in the southern hemisphere is 0.5 times by the probability it hits water, which is 0.8, and that's going to give me 0.4. And then the last one. Okay, so hopefully you guys got that one. The last one, what is the probability it's going to hit South Africa? Now remember, along this arm, there was a 5% chance that it hits South Africa if it hits land. So therefore there's a 95% chance of hitting elsewhere. So if I want this outcome, the probability of it hitting southern hemisphere, land, and ending up in South Africa, we times 0.5 times by, remember we're going along this arm, 0.5 times 0.2 times 0.05, and what does that give us? Quickly, let's do that on our calculator. So we've got 0.5 times 0.2 times 0.05, and that gives us 0.005. So it's 1 over 200. All right. All right. Did people get that answer?
No, actually, that was a bit of a struggle for the mindsetters. But yeah,
Everything
the other
else they
answers were
got.
correct. So They're on a great
All right,
track.
great. So if you've got the tree diagram, it becomes much, much easier to answer this question, right?
All right.
Okay, great. Mindset says it is my last live show with you guys on a Monday at this time. So I just want to say something really corny. For the exams, just give luck a rest and just do your best, Queen. Good advice.
That's some great word of advice from Natasha there. So you heard her, guys. Do your best and everything else will work out for you. Put in the hard work. Don't just expect results to come in. You have to put in the hard work. And unfortunately, we've reached the end of our show. But remember that we will still continue with revision from next week on. And it is goodbye from myself and Natasha. We'll see you guys next time. Bye.